Hello everyone, this is Dr. Lennon, and I wanted to walk you through problem number 4 on MindTap about the radio, television, online marketing campaign problem where we're trying to maximize our audience exposure at a cost of $18,200 in Part A based on a number of constraints. So the first of those constraints is that the radio advertisements can't exceed 50% of the total advertisements. In addition, television should be at least 10%. And is there anything else? We have a maximum number of ad buys that you can have for each of those as well. So that'll come out to about 5 constraints. Or maybe if we think about it, 6, right? Because we have the total amount we're allowed to spend. We have the max usage for each one of 3 of these, so that's 4. And then we have the constraint for the radio and the constraint for the TV. So that's a total of 6. So let's look on this one. Oh, also I've run the solver already, so it's optimized. But what I did was I just copied the chart in right here. So this is the same chart you see there. And then I created TV, radio, and online. And the total buys is the number of ads of each type they're buying. So I initially set them off as 1. We're just treating them like variables, but we have to initialize them with a value before we use solver to optimize them. And then you have the cost. The way you get the cost is you just take the cost times the total buys for each category. So 300 times 1, 600 times 1. And you'll notice right now the cost matches this second row in the constraint box that I have up here. So if I hit Control and tilde to see the formulas, you'll notice again that the formulas I'm using are just exactly what I said. We multiply the column here by this row there, and we get the cost. And then the total cost is just the sum of these 3, C8, C9, and C10. And then to get the percent of buys, because some of the constraints are based on a percentage, you just take each of the single costs by category and divide by the total cost of all 3 ads that you're spending. And then the audience contact, this is the thing we want to optimize. We want to maximize this exposure. We have this contact number for each value, and what you do is you just take the buys times the audience size and then add them together. So we have the buys times the TV exposure, B2 times B8. Then we have C2 times B9, the buys times the radio audience. And then D2 times B10, the online audience times the online buys. And then I also made one for the total number of buys, because we know that the total number of buys needs to be constrained. Excuse me, when I made the percentage, that's why I did the total buys. The total buys is the sum of B8, B9, B10. So when you do the percent of buys, what we're doing there is we're doing B8 divided by this B17 total buys, and percent for radio would be B9 divided by B17. And finally for online, B10 divided by B17. So those are the formulas we get. Now let's look at implementing the solver with the constraints. So we click the solver box, and we have the 6 constraints. So first of all, the audience contact, that is what we're trying to maximize. Then we have the changing variables, the TV buys, the radio buys, and the online buys. And, okay, sorry, I had a brief interruption there. I had to take a quick phone call. So, all right, so we're setting up the solver. We're optimizing the audience contact. Our changing variable cells are B8, B9, B10, the total buys. And then what are the constraints? Well, we had B10 less than D4. Let's find B10. B10 is online. That needs to be less than B4. Okay, so this is just saying that the most buys we could have for each category are these. So we want B10 to be less than B4. We would want B8 to be less than B4, B9 to be less than C4, and B10 to be less than D4. So is that what we have? Yeah, B10 less than D4, B8 less than B4, B9 less than C4. Okay, then we have C12 less than 183,000. So actually that I believe is part B. If we look back here initially in part A, it's 8,200. And then the follow-up question is how much would the audience contact increase if an extra 100 were allocated? So the only difference between part B and part A is we up the price from 18.2 to 18.3. So for now, we want to change this one. We want to change this number to 18,200. That's the total budget. So that's has to be less than 18,200. Then we wanted to make sure that the TV advertising was greater than 10%, D8 greater than 0.1, and D9 less than or equal to 0.5. And then for this problem, we have to run it as nonlinear because creating these percentages, we're using, in some sense, division by variables. I couldn't think of a better way to do it, but this is fine because we're going to be doing nonlinear next. And that's all it is clicking a different option when you're not just taking variables and adding them together. So if someone thinks of a better way to do it with linear simplex, that's good. But I mean, notice the way I have my model set up, I get an error and it won't do anything. So we have to run it as nonlinear, but we still get the optimized solutions. So notice now we get the buys of 4, 14, and 10. So for 14, 10, and then you can fill in these amounts here. The total audience reached is going to be important for us. The audience is this. I want to save this number just because when we run it again, we're going to want the difference. So 10520000. Okay. So 10520000. So let's check the work. Okay, great. So we have those. Now part B, how much would the audience contact increase? So what we want to do is we want to run the solver again. Okay, so run the solver again, but we want to change this again to 18,300. And we change it to 18,300. Solve it now. Notice we have a different solution, and we want to know the increase. So essentially what we want to do is we want to do this cell minus the cell that I saved from last time, and we get 5130, 5131. Who knows what it wants? 5131, let's say. Okay, let's try 5130. Okay, there we go. So it doesn't want you to round it up. All right, so that is it for this problem. So hopefully that answers all your questions, and look forward to hearing from you. Thanks.